Today we finish our set of lectures on the different methods for empirical software engineering with systematic mapping studies and systematic literature reviews. What are these names? What are systematic literature review and mapping studies? Basically, are glorified school researches in the era of the internet. While you were going to school and you were a kid, your teacher may have asked you to search some books or search in internet about Napoleon or other important events and people in the history, and report this information. Basically, systematic literature review are glorified form of this type of researches that you used to do. And of course, the keyword is systematic, and we will see that that this is really the key thing that makes them much more different, of course, with respect to what you did at school, and much more useful also. Basically, what you do is selecting a set of keywords, for example, keywords of interest for your research, that may be artificial intelligence and testing, and then retrieve papers from different scientific databases that are specialized databases for scientific papers, and then analyze all these papers, so these articles, these publications coming from conferences, coming from journals, and published in the past, and analyze them one by one to gather some knowledge, to group the information that you can gather from this paper into some structured knowledge in a systematic way. So the keyword here are structure and systematic. You will see what we mean straight away. So you start here is like a very simplified way of looking at systematic literature reviews and mapping studies. We will see the differences in a few slides. So you basically start, as I said, with relevant keywords, keywords that are relevant for your research questions, because again, you always start your research from some research questions to address. We'll see typical research questions for this type of studies later on. So you start with keywords that are relevant, you search in the scientific databases, you retrieve a set of papers, and then you identify those that are relevant, that are actually relevant, because of course, like when you search in Google, not every result is relevant. The same thing happens when you search in these specialized databases. You select the relevant one, and then you classify them. You provide statistics about the content of this paper and also the demographics of this paper, and you can extract also structured knowledge. So not just statistics and numbers, but also knowledge. So information that can be used by other researcher to build on top of researches of others, researches of the authors of the article that you gathered, and your research itself, because it's a summary of what has been done in a certain field, in a certain field, like for example, artificial intelligence and testing in this example. Where are positioned with respect to our ABC framework? They are of course positioned in this bottom left corner in the formal theory area, because with this type of studies, you basically elicit structured information that represent a form of theory for the specific field. A theory that uses that only method that we didn't consider in our previous studies, that is abduction. So up to now, we've spoken about induction for the qualitative studies, deduction for the controlled experiment, combination of induction and deduction for the case studies, for example, that we saw last time. In this case, we use abductions. So that process that takes different existing evidence and theories developed by different authors and built on top of this of these theories another overarching theory, a theory that summarize the content of the different paper. And so this is similar to a mathematical model, but for software engineering, so for our field. So what is the motivation for a systematic mapping study? Now we will start looking at the main differences between systematic mapping studies and literature review. In this lecture, I will explain basically only systematic literature review, because the process is the same for mapping studies. It is just more complex for systematic literature review. So I will explain you systematic mapping studies just in one slide at the end of the lecture. But here it is useful to make a distinction, because also in the literature there is a lot of confusion between the different names and different terminology that is used. So when to use a systematic mapping study? Let's read the slides. Sometimes we do not know enough about a certain software engineering field, and we want to know what is the state of the art. So to identify possible research directions. This may be at the start of a PhD, of a research in a certain field that I'm not an expert about, and I want to understand what is the state of the art, what is the most recent research, what has been done in the past, and this is the utility that drives my study. So I am curious about a certain topic, and I want to explore possible research directions. In other cases, we need to create a framework of concepts to understand an emerging software engineering field and identify limitations and opportunities for research. This is a slightly different case. For example, you have seen in the latest year, for example, a large use of machine learning techniques for software engineering. You understand that this is an emerging field, but since it is emerging, it's still confused, it's not clearly conceptualized. So there is a need for understanding and classifying the different studies, and understand what are the research gaps in certain areas, to understand why there are these gaps, why certain directions are not explored at all, and what would be the possibilities and the opportunities for research in that directions. What you do in a systematic mapping study, basically you can search literature, but in a study to address, let's say, this type of motivations, is that you could search the literature, but the real issue is that if you do a traditional search, it's very hard to demonstrate that you have considered all the possible scientific sources of information. So if you want to provide a general theory, and you want to provide a complete view, you need to make an effort to retrieve all the information that is relevant, or the papers that are relevant. And in addition, if you don't do this in this way, it is simply hard to replicate the study. And we know that replicability is one, and reproducibility is one of the key issues in empirical studies and in science in general. So a mapping study addresses this motivation, and the fundamental goal of a mapping study is to build a classification scheme and structure a software engineering field of interest. Of course, here we are speaking about software engineering, but this type of approach can be applied to any field, okay, to any field of research where you have a structure of the field based on a policy based on publication articles, like any scientific field, okay? So the goal is to build a classification scheme, and the method is simply define a study protocol, collect the papers from the databases, screen them. As I said, you get a lot of papers, and identify categories and present results with plots. So some statistics about these papers. We will see about the different categories of paper. We will see some example later on. The contribution, as we have already understood, is to identify research gap and therefore novel research directions in a certain area, and understand what needs more investigation, and also provide a common terminology for the field. This is really relevant. I highlighted this because if you are in an emerging field, very frequently also the language is emerging, and the community has to agree on the usage of terms, and you need to establish common terminology when you speak with each other. For example, also for empirical software engineering, it is not an emerging field because it has been there for quite a long time, but still there are some terminological issues, for example, between case study, action research, improving case study, field study. These terminological issues that are still not solved, in my opinion, and we have to live with this ambiguity, are terminological issues. And of course, empirical software engineering is extremely vast as a field, but for smaller field of research, probably identifying a common terminology can be easier and can be extremely useful to perform a mapping study to identify the categories and the name of the categories that provide the terminology for the field. For systematic literature reviews, the motivation is slightly different. Why? Because for systematic literature review, the motivation is related to the need to search for a specific answer to a research question or a set of research questions. And I know that the literature includes different studies regarding my topic of interest, and I can find the answer to my question by combining the content of these different studies. Or there might be a situation where I have different experimental results concerning a certain topic, and I want to compare them. So I want to know, for example, what is the impact of user involvement in requirements in system design, and I want to compare what the different studies say about this topic. And the goal in this case is what I was saying at the beginning, is to create a theory by adduction, by generalizing from these theories found in the literature and related to different experimental results. So also here, in this case, utility should drive the question. So in this case, probably I already know something about the field. I'm not a complete novice, but I have some research question, and I know that the literature includes different studies that concern my topic of interest. And the other issue are again coverage and reproducibility, like possibility of replication of the study. For this reason, this study, this systematic literature review and systematic mapping studies are actually systematic to ensure reproducibility and to ensure coverage, of course, so complete coverage of the published literature that is relevant to a certain question. So the goal of a systematic literature review is to get an answer to a set of specific research questions related to an area of interest. The method is to define a study protocol, collect papers from databases, so like for systematic mapping studies, screen them, identify categories. So you do the exact same thing that you do in systematic mapping studies, but then you read the papers in depth, you extract relevant data from them, and this means also doing, in several cases, qualitative analysis with coding and thematic analysis like we learned in the past, present plots, so statistics like for systematic mapping studies, and abductive theory. So you can see it as something, systematic literature review, that is more focused on a certain specific question. So normally in a systematic literature review, you also consider less papers. There are less papers with respect to a mapping studies. In a systematic literature review, you can have less than 100 papers and still have relevant content. In a systematic mapping study, normally you consider 200, 300 papers. Okay, so these are also indications, general indication of what specifically is a study based on the number of papers. Of course, this is not a general rule, but in general, it is like that. Systematic research review, of course, are related to a more specific research question, and this specific research question is answered in a more limited number of studies than a systematic mapping study that you understand tries to cover a field of research, so it includes many more papers, but you cannot, of course, read them with the same depth of the papers that you consider in a systematic literature review. So the contribution is to identify answers to specific research questions and identify a general theory about the topic of research. So this abduction process that we spoke about. Of course, also in systematic mapping studies, you can speak about building a theory, but the theory in systematic mapping studies is mostly descriptive because you create a categorization. So it's the weakest form of theory, if you remember our distinctions in the past. So if you want more refined theory, you need systematic literature reviews. In both cases, the approach is abduction. What are the way to distinguish also whether you're doing a systematic literature review or a systematic mapping studies? Well, first of all, you have to remember that they are considered secondary studies because the sources of information are primary studies, so primary empirical studies. There are also so-called tertiary studies that collect different systematic literature reviews. So you understand that the level of theory is even higher. But of course, these are developed when there are many secondary studies in the field, and the field has been developed for a long time. As we said, for systematic literature review and mapping studies, their method is similar, but you have already understood that the goals are different. So the rule of thumb to decide whether to carry out a systematic mapping study or a systematic literature review is the following. If your research questions require a general classification of the papers, the scope is large, and you are mostly focusing on the methods of the studies, so the methods that are adopted in the different studies, you are doing a systematic mapping studies. Okay, so on the methods, I mean the methodological aspect, the methodological part, and the things that allow you to perform a classification based on the method. We will see the distinction between the methods and the results in the following slide. But this is to let you understand that you are more focusing on the distinction between the higher level aspects of the studies. Instead, if your research questions require to extract specific information from the papers, and you are comparing the results, so not the method, the results of the different empirical studies, then you're doing a systematic literature review. So this is a simple rule of thumb. Okay, method for classifying, for example, different method for automatic test generation. Results, if you want to understand what are the differences between the results obtained with these different methods of automated test generation. So in that case, you are more likely to need the systematic literature review. In case you require both, so classification, but also classification at a general level, but also answer to specific research questions, you're doing a systematic literature review because, of course, you are doing something that approaches both aspects and extract information from both parts of a paper, the methodological one and the results one. The reason why so the question is, why should someone do a literature review in a systematic way, or a systematic mapping study, because if you are starting a research endeavor, you will have to make some literature review anyway. So you have to search the literature, because you know nothing about a certain research field, and you need to know what is the state of the art before advancing the state of the art. Because if you don't look at the literature, you may develop something that was developed before, and no one will publish it. And also, performing it in a systematic way allows you to publish it, allows you to publish this literature review. And we will discuss a little bit more at the end of the lecture what can be the utility for the community of this type of studies that I anticipate are quite difficult to carry out, because require to deal with they require a lot of organization, let's say. So let's start with systematic literature reviews. In theory, systematic literature review is made of 3 steps. So you define your research questions, like we learn to do for any type of study. You define a study protocol, so a set of steps that define the strategy that you will follow for throughout the literature review. Then conducting, so search papers and synthesize the data, extract the data from these papers, and reporting, so document your results, validate them, and report them in a paper that hopefully will be published and will be cited by other authors. Systematic literature review should appear in the reporting like they were conducted in this way. But in practice, as we have already learned, several iterations and adjustments are required, like in experiments, like in any type of studies that we considered. Even if then you report it in a paper that is linear, the reality is much more iterative. So several iterations are normally required. Of course, the research question may change based on the retrieved data, because until you are in front of those papers, you don't really know what's going on in a certain field. Even though you think you collected the main studies, you really find corner cases that are not really in the field, but still may be relevant for your research. It is an interesting and tricky experience. And the theory is built incrementally and may need to be changed. So you understand that it's systematic, but still systematic doesn't mean linear. A more realistic scheme is this one. Please take your time to look at this diagram, because we will follow it throughout the lecture. And now I will give you some basic information. So at the center, let's start to look at it from the center. We have scientific archives and reference management systems. So scientific archives are these specialized libraries. They are normally IEEE Explore, ACM, Springerling, Scopus, Web of Science. So a set of typical repositories in internet where you find scientific literature, and this is a list that is particularly appropriate for the computer science and computer engineering field. So here you normally find the papers that are relevant to you. You can find the papers also in Google Scholar, which is frequently used, but does not allow you to perform a well-structured and replicable systematic literature review, or to maximize replicability, because mainly because the number of results that you get with Google is really too much with respect to the results that you get with this other engine, and many things may be irrelevant. And in addition, Google does not allow you to create quite complex queries like the one that we can issue in these scientific archives, to reduce also the number of papers and to be more focused on our search. So scientific archives are at the center of the research and will be your reference. You see that they are in the whole in the whole process. They are at the center because you will use them until the end of the of the review, of the systematic research review. And reference management system. Reference management system are instead systems like Mendeley and Note and Zotero. Zotero is free and it has also plugins for your browser. And basically, you explore the scientific archive, you find a paper, you can add it to a local repository that allows you to extract in an automatic way all the bibliographic information, so authors, titles, publisher, type of venue, pages, etc. You may find this as not so relevant, but I can assure you that when you deal with 200, 300 papers without such a system, it is very complicated. It is very complicated to follow on in your literature review in a systematic way and prevent and avoid losing studies. So let's go instead across these different steps, and then we will see them in detail. So first of all, you need to specify the need for the systematic literature review and specify your research questions. So you need to confirm that the review is actually needed. You perform a pilot search. So this is a key thing that is important. You write sort of initial set of keywords and you perform a first search. Then you write, based on the pilot search, you define the protocol. The protocol defines all the other steps that you see represented here, all the other steps that are needed later on in your research. The research is made of a primary search and a secondary search. The primary search is the one that you do on the web. You write your keyword that you selected during the pilot search. Then you get some papers. You don't read them extensively, but you just read the title and the abstract, you screen them, and you decide whether to include or exclude them, because you can easily understand in this phase whether they belong or not to your field of interest. Okay, if it is not clear from the abstract or the title whether it should be included or not, you can take a look also at the content. But this screening activity, since you may retrieve a lot of paper, the screening activity should be quite quick. Then you do your full text download for those papers that are relevant to you. So download them in your reference management system, and you do your full text screening. And you may need to exclude some paper that at the beginning they looked relevant for your study. And during this screening, you also perform a quality assessment. So you judge these studies whether they are not just relevant, but they have sufficient quality. We will see a checklist of qualities that are expected from the papers. Then this is not sufficient, because we said that we want complete coverage. How can you be sure that although you've searched with keyword in all these databases, because this primary search is performed in all the databases, you didn't lose something? So the secondary search uses other strategy, for example, the so-called snowballing. That means I check the references of all the papers and see if the references that are relevant for me are included in the set of the papers that I identified. Or you may check manually some venues that are important for your field, or some publications of very relevant authors. Okay, or ask someone in the field whether they see something missing. Also doing this on Twitter can be useful. For example, if you tweet the draft of your research and ask other researchers whether something has been missing, they will provide information to you. Then, of course, you do for these other papers, you do the screening with the inclusion and exclusion criteria, and of course quality assessment. Again, at this point you have all your papers and you perform the same step that we do all the time. So data collection and data analysis. Data collection here is called also data extraction. You extract your data that are relevant for your research question, and then you analyze them and synthesize them. So you provide a theoretical synthesis, and then you report, of course. So let's see the different steps in more detail. First of all, we said that we need to be clear that the systematic literature review is actually needed. So we need to provide evidence that this is necessary. Okay, when is it not necessary? First of all, if there are already some reviews on the topic. So if your review is on automated testing by means of artificial intelligence technique, and there is already a systematic literature review that is speaking about this topic, then your review is not needed. But it is not needed also if you find that there are very few papers that touch your topic, okay? Because in this case, probably your review is needed to show that there is not so many studies in that topic, but no one will publish a systematic literature review on 10 papers. So it's not really needed to do it in a so systematic way. It's better if you enlarge your scope and extend your scope. So the rule of thumb for understanding whether it's relevant or not is go to Google Scholar. So the website that I told you before to not to consider because it's not appropriate for the systematic literature review, but is extremely appropriate for this initial phase. And you go to Google Scholar, you search for artificial intelligence and testing and synonyms, so terms that are related to your research and relevant for your research, and search also the other terms like literature, review, survey, mapping study, state of the art. So these terms that normally represent, if they appear in the title or somewhere, they normally represent a systematic literature review or a review of another form, not systematic, on the specific topic. Another rule of thumb is to search the most recent high quality papers about your topic of interest. By high quality, high quality here we mean that are published in important venues. So important venues are venues with, for example, IIT transactional software engineering ACM surveys. So you will know which are the important venues of your field of interest by asking, for example, your supervisors or professors. Okay, but the important thing is that you check for papers of your topic of interest that have high quality. Check the related work section, because if it's a good paper, there is always a related work section, and see if they refer some survey or review that is speaking about the topic of interest. So you find a paper that is speaking about artificial intelligence and testing because it's applying a method. This paper will include a section with the related work, and in this section, of course, there may be a reference to a survey in the field, so to another paper. And it is important if this is not, if you cannot find another review and none of the paper of high quality refer an existing review, then probably it is likely that there is no review that covers that topic. There may be related reviews, of course, that you need to reference, but not a review that is specifically on your topic of interest. So in your report, at the end, you will need a section in which you refer to previous studies and explain what your review adds to the body of knowledge. For example, here this example is this illustrative example clarifies this aspect. There may be reviews on testing techniques, but no review is focused on effectiveness of testing. So you have systematic mapping studies on testing techniques, but there's no actual focus on questions related to effectiveness of testing. And at the same time, there may be mapping studies on artificial intelligence and testing, but none of them is focused on effectiveness of testing again. And there is a review on this topic, but it's very old. It's 10 years ago. So in the last 10 years, there may be many more studies, and you have to check that, of course, that this is true. So if you find that there are related reviews, but no one is dealing with effectiveness of testing, that there is space for a new systematic literature review on this topic. So you understand, you intuitively understand that a systematic literature review is needed if none of the existing papers cover that type of topic. But these need to be made evident, okay? Which are the issues that may trigger a research question for a systematic literature review? For example, assessing what is the effect of a certain software engineering technology. For example, I want to understand what is the effect of introducing UML or some model-based development activity in safety critical companies. And this is the question that I want to answer with my literature review. Or I may want to assess the frequency or rate of a project development factors, such as the adoption of a technology, or the frequency rate of a process success or failure. So this is more refined to understand what is the state of the practice or state of the art for the relevance of a certain technology in a certain field. Identifying cost and risk factors with a certain technology, the impact of the technology, and perform some cost-benefit analysis. These are all possible triggers for a research question that you find in this reference from Kitchenham. That is one of the mothers of this type of studies in software engineering. So here you are some examples of research questions that are typical for systematic literature reviews. You see that already looking at the questions, they are not so different from the question that you have in the other type of studies, you know? Because here you ask, is there a relationship between user involvement and the success of a software systems? This is a typical question that you could ask also for a case study or for an experiment, for example. You could answer in that way. But it's more likely that several people have studied this quite general problem in different, according to different perspectives, and answering this question may be easier by collecting information from the literature. This is a general question, so you can define it before the pilot search. Remember the pilot, now we will see a bit about the pilot search in the next slides, but the pilot search that you do as a preliminary step. But this is an initial question that is sufficiently general, and even though you don't know much about user involvement in software system, you can formulate it. The second is slightly different because it's more detailed. What should be the degree level of user involvement in software development to achieve desired results? So in this case, you already know somehow that in the literature that there are different studies that speak about different levels of user involvement. So you know already what's in the literature. You have performed already some pilot search, and you can formulate also this question. Okay. Otherwise, if no one of the paper speaking about the degree or level of user involvement, of course you don't have an answer to this question. Okay. So it's useless to ask it and to put it in place. This is even more detailed. What is the effectiveness of artificial intelligence techniques in predicting software bugs? So this is very detailed because it's bug defect prediction, bug prediction, and artificial intelligence techniques application and effectiveness. So you have already done some classification of artificial intelligence techniques for bug prediction, for example, through a systematic mapping studies. then you have understood that there are some segments of research, and there is an established terminology, for example, also, and you want to answer a very detailed question. So the first question is more general, and you can define it before the pilot search. The second question is more detailed, and you may define it after some pilot searches. The third question is more likely to define it when there is already a systematic mapping study, and you already know that all the papers can be compared based on the effectiveness, because otherwise such a question is not relevant. And the last one is, again, a very general question like the first one. So what are the human factors that affect project failure? In this case, you may define it. You see that this is more general than the others, and you can define it since the beginning. Of course, for a single study, you can define how many related research questions you need. Important thing is that you have some information to write about each question when reporting. Okay, so you can ask any question you want, but the important thing is that when you report the results, you have a question for what is the effectiveness of artificial intelligence techniques in predicting software bugs. If you find no paper speaking about this, or about the effectiveness of the technique, then you have no answer to this question, and so you will not report it in the paper. So you have to always, even though it's the beginning of the research question, they change, because you may find a paper that lead you toward a direction, and paper that let you exclude some research question because there's no answer in the literature. So this is a tricky aspect, a relevant aspect with respect to the other type of studies, because while in the other type of studies you can transform somehow the reality to give an answer to this question, here somewhat the answer to the question is already there, is already in the existing knowledge, in the existing publication, and if it's not there, then the answer also doesn't make sense. So defining research questions. As I said, it is very hard to have a list of well-defined questions since the beginning, so they will evolve for sure. But a possible strategy is to identify the element of interest for your research question. These are basically somehow similar to the concept of context that we discussed. So the different categories associated to your context of interest. So type of human subject, so the developers, the users, the testers, the managers, these are the roles that may be relevant for your focus. The artifact, that may be the code, the requirements, the test cases. Methods or technologies, for example, this is more vast than this simple list, but maybe artificial intelligence, the use of Scrum development, the use of questionnaire. So what is the technology that you want to that these papers that are interesting for you will discuss, the specific software engineering tasks that you are addressing, the focus, so the type of variables that are relevant for you. That can be reliability, bugs, happiness of people, effectiveness, or simply affect if you're studying just a relationship. So this type of focus, this type of variables. Then spatial scope and temporal scope. So spatial scope can be in the research, or in the large companies, or in small companies. By research, I mean in the area of simple of studies that remain at the research level and are not concerned, for example, with case studies. Or my scope may be large companies, or my scope may be small companies. Temporal scope and can be or studies that address short-term aspects or long-term aspects, or the shift from one phase to another phase. So this is another dimension of interest that may be relevant for your research. Then you select what is interesting for you for this element. Of course, granularity in this element may vary, and not all the elements are relevant to you. But this is a good blueprint to select what is relevant for you. For example, for you is not relevant whether you're dealing with large or small companies, or the temporal scope is not something that is relevant for your study. So you are not interested, for example, to compare what is the short-term effect of usage of artificial intelligence compared to the long-term effect. Okay, so, or what is the utility, for example, of having repeated elicitation meeting before actually writing down the requirements document. I don't know. I'm inventing at the moment. So maybe the some of the dimensions are not relevant to you, so you don't consider them. But this list is at least complete, sufficiently complete for you to guide the formulation of the main research question. And the example can be, what is the effectiveness of artificial intelligence technologies for testing? So in this case, I'm just taking the effectiveness, so a focus, the variable, and artificial intelligence methods or technologies, and the testing as a software engineering task. Okay, so these are this is an example of how to properly formulate the research question to consider the aspects that may be relevant. Okay, let's go to the pilot search. Pilot search is probably the most important step of any systematic literature review, because it's the key to define the research question. Because until you try, as I said, you don't know what's in the literature until you search the databases, and you don't know what is the actual literature review process. So perform the pilot search not one time, but several times. So it should be pilot searches instead of pilot search. Basically, it is key also to define the keywords that need to be used, because in my example, I said just artificial intelligence and testing, but there may be synonyms to be used that depend on the terminology that you use in the papers. Some synonyms are directly supported by the engines, but not all synonyms. So it's you have to tune your keywords also depending on the engines. The keyword and the search string. We will see what is the search string straight in the next slides. And the pilot search is key also to understand whether it's the case to pursue the systematic literature review, because in the pilot search, very typically you find other reviews on your topic, because systematic literature review and mapping studies are very, very frequently cited. And so they will be found first during the pilot search with the keyword of interest. The pilot search is also key to align the viewpoints of the different reviewers, because if you are dealing with 200, 300, 400 papers, you cannot do this effort alone. Okay, so you need to parallelize the work of paper screening and data extraction and data assessment. So this activity needs to be made in parallel, and the reviewers need to have the same mindset, the same point of view. So this alignment is made during the pilot search, where you are less systematic, more free, and you are working towards the definition of a systematic way of working. Most of the time, there will be one reviewer and one supervisor or assessor. But in several cases, you may be in more people, and you need to carefully consider the different viewpoint and align this viewpoint. If you don't find evidence of what you search, the number of retrieved papers is low, or they have poor quality, then do another type of study. Okay, so do an experiment, do something else. So if your search didn't lead to any relevant answer, probably either your search was badly expressed, or there is actually no research in that direction. So you need to start the research in that direction, and do another study on that topic, for example, an experiment. But still, you need to motivate that the study is actually needed. So pilot search. Pilot search is simply a set of unrestricted trials in which you first define a draft of your protocol and then you apply it. Okay, you define the protocol, the list of steps, and then you apply it. The pilot search does not follow any specific guideline. The goal is to incrementally define the study protocol. So first you select some keywords and databases, retrieve some studies, check a relevant part of them, try to discard those that are not interesting, and try to understand what are the characteristics of the not interesting one, try to extract the data of interest, so the data that may answer your research question, try to refine your research question, and modify these keywords, search additional databases, because, for example, you are covering a field that is not strictly in software engineering, but it deals also with some aspect that may be published in psychology journal or teaching related journal or medicine journal, because as we know, software engineering is a field that has several borders in common. The borders are not well defined with several other disciplines. So you may find relevant papers in other areas, so you may need to search for other databases until you are confident that you can do the same thing with all the studies, and you can report the whole study like it was done sequentially. Okay, but like adjustments will be needed until the final reporting. So you do this pilot search to understand that you can do the same thing with all the studies. You can extract the data, you can discard the irrelevant one, and you can report everything like it was done in a sequential way. So what is the protocol? We've spoken about the fact that we are doing this pilot search, so searching keywords, synonyms, trying out this the actual search, and the goal is to define the search protocol. The structure of the search protocol is this one. You have to define the primary search strategy and search string, the secondary search strategy, what are the inclusion and exclusion criteria that you apply when you read abstract and title to discard irrelevant studies, the quality criteria, that are the criteria that you apply to judge the relevance, basically, of the papers based on their quality. So after you screen the irrelevant one, you may also want to screen low quality one, or at least you want to assess what are more relevant in terms of quality and less relevant in your set of studies. Because these affect data collection and analysis, of course, and that are the activities that you do at the end. So in the protocol, you explain everything that you will do later. Okay, so it's a recipe for your study. Now we will see these four initial phases. So let's start with the primary search strategy. This primary search strategy simply means the retrieval of studies. So the papers, articles, all the works that you can find. You write a search string and you search the scientific databases that are also called digital libraries. These are the typical databases that you will search for computer science. For computer science systematic literature review. Note that each search engine that is embedded in this database has specific peculiarity. So your search string may need to be adapted to the user input interface of the databases. In addition, these are search engines and they vary across time. So this goal of replication of systematic literature review is not always achievable. So more than replication, I will speak about evidence of the fact that you've been systematic of your search. But since they are maintained by another subject and the interface change and the engine change, so and also the content of the databases may change, and of course change based on the evolution of the literature. Replication is not always possible, and the issue is that they can change the interface also between the start of your study and its publication, because it's because their rights is they are not waiting for you to finish your systematic literature review if they want to update their own search engine. The primary search study needs to be complemented with a secondary search, because you are never so sure that you collected all the relevant studies, as we said already. So let's see an example that is the easiest thing. So here I am interested in, this is taken from this paper that you can check from Chen and Ali Barbar. Here I'm searching about product lines and software product lines and variability. So I'm doing a search on what has been done in the topic of software product lines and variability. Here you see that the search string is made of keyword and combination of keywords combined with and or. So the or combine, of course, the synonyms, and the and combine the keyword that are relevant for your searches. The search string, this same search string is formatted for the different databases in a different way. So you see in the first database, in IEEE Explorer, you see that it's quite complicated with several parentheses. Instead, the dialect for the ACM is completely different. So each of these database has a different way of formatting the same content, okay? And you need to adapt the search string for the different content. For example, if it's too long, some of the search engine does not allow you to use a long search string, these long search strings. So you may need to separate it. So also this creates an overload of work that is not negligible. How to define the search string? This is the most common way that is not rigorous and is normally accepted. So you define the keyword, the main term, based on the aspects that we considered at the beginning. So the various elements that are relevant for your research. So the human subjects, the artifact, the methods, software engineering tasks, and the focus. For example, I'm interested in user as roles, so as human subject, involvement as the focus, and software development as a general task, that is the overarching task of software engineering. Normally, in the spatial scope and temporal scope are not part of the string. This is something that you search, that you may search later on in the paper themselves. Okay. Then you determine and include synonyms, related terms, and alternative spelling for main terms. So user may become customer, consumer, and user. So you include also the synonyms. Check the keywords of any relevant papers that you already know through the pilot search. And thanks to the initial searches in the databases. And so they may use not just involvement, but they may use involvement, participation, contribution. User involvement is UX. So these are different terminology that may be used to speak about this topic in the field. So you understand that there are synonyms that need to be included, otherwise the studies cannot be found. And then use and or to mix the words. So the alternative spelling and synonyms are used, of course, using the Boolean or, and the main tense using Boolean and. So I think this does not need to be explained too much. There are also some more accurate and rigorous strategies for defining the search string, but they are not adopted so frequently. But if you are interested in being extremely rigorous, you can use this approach proposed by Zhang and other authors that is based on the concept of quasi-gold standard. Basically, what does it mean? It means that you select a set of papers that represent what is relevant for your search. Then this can be done by identifying relevant venues, screening them. So you define this gold standard, this so-called also actually quasi-gold standard. Then you write possible search string, and you check whether the papers that are included in your in your results are actually part of the quasi-gold standard, and you evaluate your search string in terms of sensitivity and precision, that are estimates that are very similar to precision and recall in information retrieval. Normally, the rule of thumb here is that if the quasi sensitivity is the sensitivity is greater than 80%, then move forward. If lower than 80%, then you need to refine your search string. What is the quasi sensitivity? Is basically the number of relevant studies that you retrieved with the specific search string compared with the total number of relevant studies that you have in your quasi-gold standard. So this is a systematic strategy to say, okay, I am sure that with the search string I can find all the works that are relevant for me, and possibly the works that I will identify with the search string will include all sufficiently relevant works. Okay. Poi, then, still on the primary search strategy, in the protocol you have to describe how do you have defined the search string, so the approach with the that you used, either the systematic one or the non-systematic one, but you need to be explicit. Find the scope in terms of years, because it is very important that you decide when do you want to start your literature review. If you are interested only in studies that are that are from 2010, and you don't want to do an historical review because there was another review, for example, then probably you need to specify it in this moment. Describe the digital libraries and explain why you search you have selected them, and this is the justification is normally that they are quite common to be used, so you refer to that paper from Kitchenham you can be safe that that your selection is appropriate, your selection of databases. Then remember to annotate the number of studies that you retrieved from each database in the final search string, and remember to annotate the date when you perform the search string, because if some papers were published afterwards and are not yet uploaded in the databases, they will not part of your results, and the reader has to know the exact day when this search was performed, and they need to know the amount of papers that were extracted from and considered from each database. Then, primary search study, you have to detail that you screen, title, and abstract, and include clearly relevant studies. If a study seems relevant, download the full text on your reference management system, that can be Zotero or EndNote, and if more than one person is involved, decide a way to resolve undecided cases. So as we said, there should be a process in which, of course, in the pilot search, you have already established a way of understanding what is relevant and what is not by looking at the title and abstracts, but there may be still cases in which you don't know, and the cases may be several. So the process can be simply that you discuss it with a supervisor, or you call in a third person to decide whether a paper should be included or not. Key thing is always keep track of the number of papers that you get and annotate the date in which you perform the search. This is just to remark this aspect. An example. Here I go to script to make you understand the difficulty that you may encounter in doing this type of research. So here I've written in Springer Link, this website that you can reach also by yourself, the following keyword that are user and involvement and software development. Okay, not even synonyms. And I find 4,097 papers, like a lot. Also, just screening titles is exhausting, it's too much. So probably it's better if I refine my search. Let's refine. I want to search just for computer science, software engineering, and conference paper or article that are journal papers, so papers in journal. And I see that there are 1,000 conference paper and 172 articles. So this seems to be more manageable. Understand that this engine allows me to select these categories. Okay, so for example, I don't consider books, but it's still a lot. And it's still a lot, but I have to inspect this paper. From a certain page onwards, I see that results are not relevant. Of course, I can continue. I can go on. Here you see there are 57 pages in this example. Can go on, but after a certain point, it becomes easier to discuss these papers directly based on the title. Okay, so 1,500 is a manageable number. Okay. In another tool, in another search engine, I might find much less paper with the same exact keyword. So only 86 papers. So you understand that synonyms may help here. But hey, but if I'm using synonyms here, I have to use synonyms also for Springer Link. Okay, so you understand that this search requires a pilot activity in any case, because you need to align somewhat the approaches between the different search engine, because they give different output with the same input. Okay, and you have to remember also that you may find duplicate studies, and this is easily handled. So the same study in the different search engine. This is normally handled by your reference management system, so EndNote or Zenodo. It is important that you remember to balance coverage. So all the studies, yes, but you have resources and you have time, and you cannot spend all your PhD or one entire year doing a literature review. Okay, and remember that in a systematic literature review, the papers that are really relevant in the end are few. In 100 paper that then you link in your systematic literature review, the ones that are really valuable and they have a high quality, maybe 20, 25. Normally, a way to understand whether it is high quality, if it is published in a high quality journal or very high quality conference, it is high quality. We said we need a secondary search strategy, so it's not sufficient the primary one. Primary one done in digital libraries. So what is the secondary search strategy? You may do some hand searches in relevant journal that you found during the primary search, check in relevant conferences, and provide evidence that you made an effort to search also studies that are not published yet, or that are part of other for example, books or other sources of information. And this can be done by, as I said at the beginning, by contacting relevant authors, for example. So you need to show that you made an effort and you did your best to identify all the studies Of course, one typical strategy is snowballing. So you search in the references of the papers that you found, and you search for those papers that are cited and check if they are relevant. And you can do also the other way around. You can find the papers that cite your relevant paper, because this can be done with Google Scholar, for example, or with all the engines, and search the paper that have been published in later years and that cite the one that is relevant for you. So this can be like a very, very long activity. Okay, so consider to spend quite a long effort, but it's very important because it's the base on which your study is performed. Protocol. In the protocol, you have to make explicit the inclusion and exclusion criteria. Okay, these are the criteria that you apply during the screening. During the screening, when you decide whether to include or not a certain paper by looking at the title and the abstract. For example, here you have the list of inclusion criteria, and I don't go through through reading all of them because it's easy for you and they have to adapt it to your research question. But in general, for example, you can have an inclusion criteria that is studies about consistency checking related to software behavioral models and diagrams. This is the relevant topic of this example study, so of course it needs to be included just because it's related to the topic. But the inclusion criteria, it can be also that the study comes from an acceptable source, such as a peer-reviewed scientific journal, conference, symposium, or workshop. So, for example, you don't consider books here. So it is you may have as exclusion criteria, for example, secondary literature reviews, of course. So secondary studies that collect other secondary studies like the one that you are performing actually, or study reports only syntactic or structural consistency checking on model diagrams. So some more detailed exclusion criteria that focused on specific aspect only. So these are criteria that are normally defined during the pilot search and that you applied later on for the screening. These are examples taken from this paper. Protocol, quality criteria. We spoke that there was this phase in which I do the screening, then I save the papers that are relevant for me, and then there is the moment in which I have to inspect the full text. This can be used, can be really useful for excluding papers that are within your research questions, but are relevant for your research question, but at the same time you see that they don't include enough information for you, or just to score them, for example, because you want to perform a mapping somehow, you want to categorize them, you want to consider them, for example, to say that in that field many papers have been published but the quality is quite low. Okay, but they may be scored because you want to elicit evidence just from a subset of those studies that have been judged as high quality. So quality criteria are really important for systematic literature reviews. And you need to define a checklist with a list of quality criteria and apply them. The quality criteria are partly general and partly based on the type of study, because the case study cannot have the same criteria for evaluation than an experiment. They are completely different papers, so you need different checklists. At that link, you find extensive guidelines. Here we see some examples. These are generic criteria for empirical studies, so general, independent on the type of study. For example, the questionnaire, is there a clear statement of the aims of the research? Is the paper based on research or just a lesson learned report based on expert opinion, for example? Was the research design appropriate to address the aims of the research? So you have to judge at the high level how good is the paper, and you can give 1 point to each of the question, and decide to exclude the paper that have less than a certain number of points. The justification of this certain number of points, of course, depends on your pilot search. So you decide the limit of the good papers after doing the pilot search and applying this quality criteria and defining throughout the pilot search. You can use also more accurate quality criteria. So a set of generic ones, so are the aim clearly stated, are the study participants or observational units adequately described? So in this case, you have a set of generic questions of your checklist, and then a set of different questions for each type of study. So for example, if you find a case study, it is relevant that you ask whether the context is well defined, raw data are provided, there is a sufficient link to the theory and existing literature, is there a threat to validity section, for example. This type of question allows you to establish whether a study of a specific type has a required degree of quality. For example, in this paper from Munirabano and Didalzovki, you see that they decided to assign a certain score for each question. So 0.5 was 0, depending on the type of answer, whether it was yes, partial, or no. And the studies that score less than 50% were excluded. So they decided to exclude low quality studies. And how did they define these 50%? Based on their pilot search, of course, because they found that those that were lower than that boundary, they were not providing sufficient information. So you understand that there is rigor, but this rigor comes from also quite qualitative personal decisions that you can take only based on knowledge that you've gained in the topic through the pilot search. So let's have a break now, and then we see data collection and data analysis.